Hello, everyone, and welcome back. My name is Corey, and I guess you're my rubber ducks for the evening. And we are in the middle of, well, we're recording a long series, that is, um, where we are creating a programming language from scratch. And each episode, we aim to implement some feature of the programming language. And we've done a lot of work. And this time, I want to get the wording right. I'm going to put the title screen back up there. Yeah. Native bound functions. Now, I've said this from the very beginning. This is 100% live coding, right? Nothing up my sleeves. I don't have anything pre-prepared. And sometimes that's dangerous because you see me live coding. That means my mistakes and everything. But just to demonstrate, if I say git log, you see that the last commit was the end of the previous episode, episode 55. And then, of course, if I say git show, there are changes. Why is this? Oh, I say git show. Git status. Git show shows the last commit, and it was, of course, documentation. Git status. There we go. No files have changed. So I am in my base directory, and on the right hand side, I'm going to make clean and make it and have it start a new compile. Test watch. All right, and now what is a native bound function? Well, first of all, let's cover what do I mean by native. We already have functions in our language, but we have functions that are defined by the in the code itself. Right? You could write a function to compute the Fibonacci sequence or something like that, and we support recursion. But these are functions that are defined within the script code body, and they're compiled into the bytecode of our program itself. Well, that's fine, but what about a function that's written in C++ that we want to provide to our programming language? Well, that's a native function. That's what I'm calling a native function, as opposed to the compiled function. Okay, so native function means it was written in C++ and compiled into the language. That's the first part. The second is a bound function. What does that mean? Well, let's just suppose I'm going to write a test that will demonstrate it. So test.cpp, and I like the word function. There we go. Compiled. These are a test for compiled functions. And now I'll just go down a couple. The function calls, those are the returns. Pass by value versus pass by ref. I forgot we had written all this. We're just going to put it at the very bottom. There we go. And I started doing more of this scoping later, so this doesn't have it. But this is going to be a bound function call. And so we're not going to declare a function. We're going to have maybe a is equal to hello world, and we're going to say print a dot length, and of course if we do p1 execute out, what should it output? Hello is 5, world is 5, so it should be 11. A length of 11. That's the goal. And this is being called function compiled. It should not be. Let's call this how about class function? Class functions string. A.length hello world. That's what we're going to try. And to tell you the truth, that's all I'm hoping to get done in this, because there's got to be a lot of groundwork laid for this to work. So, it's really raining outside. I doubt you can hear it, but it's really raining right now. So A is an object. It's a string object, but it's an object nonetheless. And when I have this dot here, it is going to, oops, didn't mean to highlight. The dot there is going to call the dunder period method, and that's going to be, there we go. So it's going to call the dunder period method on the A object, and that should return, and it's going to provide it with the word length. So it will call dunder period and provide it length, and that should return this new idea of what we're talking about, a bound function. So what is a native bound function? So what does the bound part mean? Well, the function should be obvious. It's a function that's going to return length, but the length of what? Well, that's what it's bound to, the A object. So the A is a reference that will travel with that function and that we should be able to execute. And if we make another one, and so this is a bound function GNME assignment, if I were to, if I were to say B is equal to A dot length, again, this should return a bound function. So B itself should contain a reference to A. I'm not saying we should be able to retrieve it, but it should retain that reference to A, or the hello world. And if we want to further test it, we could say bound function assignment does not change. If I were to say A is equal to goodbye, it should still print out 11, because B is a bound function, and the bound function will be have saved with it the reference to whatever A was pointing to when it was created. So all of that is the goal. And if I also print out, no, wrong letter. How long is goodbye? 7. It should print out that 117. All right, so I'm saving this. It's not going to work. May even give me a segmentation fault. No, it doesn't. That's good. I'm glad. But it doesn't print out anything. All right, now we get to start making some stuff. So a native bound function. Native means we're writing it in C++. Bound means it's going to be bound to some variable. And now we get into some problems. First of all, look at how we instantiate, or how we get a script. We instantiate Tang base, and we've been doing this all through here. We may change the way that we're doing this, but for right now, we create a new version of Tang base, and we call compile script, and that returns a program. P1 is that program type, and in fact, I think I've got here a copy of the documentation. This is the most recent one, and There we go. And if I look up the program class, hello, where are you? Oh, it's right there. Alphabetical order. Have issues with that, evidently. We can see that there is this really nice, there we go, visualization of the class and what everything points to. And this is the structure that we have. However, one thing that we're going to need is we are going to need to store a reference to the base Tang class. And the question is why? Why did I create it? Why did I design this language so that it had to, so that I had to create the program from, that I had to create an instantiation of the Tang base class? And the reason is very simple. I wanted the developer, whoever's using this, whoever's implementing or making use of this language library, to be able to instantiate an instance of the language and then say, okay, now add this functionality to it, and it be contained within that object and it not propagate to other objects. So you could have two instances, two objects, and one of them support XYZ functions, and another one support a different set of functions, a different library of functions. And that's not required. Maybe it's over engineering, but I kind of like that idea. And I really like it for the purpose of testing, right? We can create an instance and mess it all up and then just create a new one and test whatever we need to there. We push it to its limits. Don't know in the real world how practical that's going to be, but I started off this program with that intention. However, we're not actually passing on that reference to the base class into the program, and we need to do that. We don't have any private attributes that are storing it, and we don't have any public attributes, I should say, either. So, what are we going to do? Well, I'm going to start off by going into the include for Tang base. And this is, oh wow, I haven't been in here since the very beginning. And we've got our class Tang base, and I want to be able to have it provide a shared pointer to itself. And the shared pointers, the reason is because I want you to be able to create the base, create a program, and then if the base goes away, that the program still has a reference to it and it didn't disappear because it's no longer on the stack or whatever. So do I still have that up is the question. I don't have it here. Do I have it in another screen? Maybe. Yes. Pulling it over. So in the C++ language, there is this idea of, there is a class called, not shared from this, it's enabled shared from this. Oh, there it is. Yeah, enable shared from this. And if you inherit from that class, then, well, you can give out a shared pointer of yourself. So, all right, there we go. And this is something that it looks like, right? So we have a public inheritance from standard, and we had to pound include memory. So we're going to go back up. Whoops. From this, and we have to, because it's a template, we have to pass it our class, and at the very top, pound include memory. All right. That's the first thing. and everything should still compile. And we can see, I mean, I pulled up the shared from this. This is a function now that I should be able to call. And where is one? There it is. Return shared from this. I don't like, you have seen me, I always, always, always include the this arrow because it looks like this is a standalone function, and it's not. It's a member function. So, yeah, that's what I'm doing. Okay, so now in Tang base, the source for Tang base, compile script, it's return a program that has, we pass in the script, we pass in the script type, and now we are going to pass in shared from this. And it's going to complain because program doesn't support that. We're going to add it. So edit the include for program.hpp, and I shouldn't need to pound include memory because, oh, nope, I'm going to. Wait. I'm about to get some compilation problems. Yep, I am. And I know I am. Let me just show you. Yeah. Before, it was this other stuff, and now my error is when trying to compile AST node, program does not name a type. So, why? Because Tang base tried to include program. And so what I need to do is just forward declare it, class program. Okay, that's better. I'm just promising something that it will be here before I actually need to create it. Now program here, there we go. I'm going to give it a new param, and it's going to be, just call it Tang. And we will say a pointer to the base Tang class. And this is going to be standard shared PTR, shared pointer to a Tang base, and we're going to call that Tang. All right. Still not going to like it because, well, we need to edit now the source for the, well, wait. Before we do this, we need to copy it, a pointer to the base Tang class, and we'll probably put it, let's go down. I think I like to put it as the first private. There we go. Shared pointer, need a semicolon. private. Do I need to do anything else? Do I need to have a getter? I don't think so. We'll find out. And now I need to edit the source program.cpp. And in the constructor, there we go. I think it needs to go first, actually. See if it likes it. Probably not. All right, so Tang base is not a member of Tang. So I might have to forward declare this one as well. I do call it Tang base, don't I? Or am I just wrong? Nope. Wait. Yeah, it's called Tang base. All right. There we go. And I should be pointing to that. All of the tests are failing, by the way. Oh wait, are they all? Zero tests pass. Okay, yeah, so they're all failing. Good. That means it's all the same problem. A bad weak pointer. Now, well, let's see what I did. So when I call compile script, I give it this shared from this. That should have worked. Anytime, by the way, anytime I'm messing around with these base things, I don't trust it. Now, it may still fail spectacularly, but get through it faster. Okay, it is failing faster. That's always nice. So, what's the deal? That's a very good question. I believe I'm still testing with GDB. So, the Unicode string stuff passed, but it's only testing Unicode, singleton object pool, and so it's just the language stuff. That's good. So build apps test. So if I gdb./build apps test, run that, bad weak pointer. Okay, I thought that, that would have killed the program. Evidently not. So, the question is, what did I do wrong? I have no idea. So what do we do in cases like this? Sure, we look at Stack Overflow. Customize settings. Turn off everything, even the strictly. See, it won't let me turn it off. That is hostile. And look. I was like, it wouldn't let you close it either. Let's just see. Oh, I think I've done this before. Um, yeah, publicly inherit. I did that. Right there. So the question is it because it's from a on an object which has no shared pointer pointing to it? Uh, man, I don't like that. Well, here's the issue already. Evidently, so it says here, shared from this, that at least one shared pointer must already have been created. Well, we haven't created one. So, that is not what I wanted. Maybe it's behind door number 3. So shared from this returns a shared pointer that shares the ownership of the pointer to this with all existing shared pointer that refer to it. Only on a previously shared object. And it cannot be shared from this cannot be called during the construction. Well, that's fine. But so what I'm not liking, well, the way that this is working, do I have the test? No, I don't. I can open that up again. the way that this runs is, let's just start at the very beginning. I call Tang base. When I call compile script, I'm saying I want to store a copy to Tang base, but what if Tang base goes away? So what really needs to happen is Tang base should never be able to be called. Rather, there should be a function that that returns a shared pointer to it. That's what it needs to be. Ew. This is a bigger refactor than I wanted it to be. So, what can we do? What I think I'm about to do... Why am I doing this? Why am I taking this approach? Because I'm going to do it. All right, so here's what we're doing. Tang base. This is now going to be called Tang. Oh, this makes me feel bad. Make shared. Why not? That's what we'll call it. And then we will say Tang base. Make shared. Anything else? Like, oh wow, this is taking a lot longer than I anticipated. Sorry, it happens sometimes. What are you not liking? So in program.hpp, oh, that's why. Okay, that's fine. Program.cpp, yeah. Where is the error? Line 17. think we got further. Ah. Doesn't like line 11, which this is the constructor. Of course, last time. Did I forget to change something back? Tang base, Tang base. Enable shared from this. Tang base. And I'm going to do something different. I'm going to, on the left-hand side, say just get diff. And, okay, so I added a forward declaration of program. I added Tang base to program.hpp. I added there shared pointer to Tang base. Have a private pointer to Tang base. Have a forward declaration of Tang base. I changed it to public. That's fine. So I removed Tang base and did that there. That's fine. Program.cpp. Yeah, okay. I had Tang and I was thinking, that's not right. Yeah. The name of the class is Tang base. That's what the problem was. All right. All right. It's the first change. We got to fix all of these bad weak pointers. How are we going to do that? Well, I'm glad you asked. In test, what I think we're going to do is have a global, and we'll just call this So it's going to be a auto Tang is equal to first, just see if that works before I go all out. That's the case. Now this one right here, this Tang base, if I replace that with Tang, the declared null should pass. Scroll up. Look, one test passed. Yay. Declare integer failed. So now we get to do this. If I say colon, no, %s, Tang base, open, close, period, and replace that with Tang arrow. Try that globally. See, if I do %s, Tang base, Tang arrow, that replaced all of those, but it's how do I match the parentheses exactly? Sorry, undid that. And let's pull up our old friend and just say vim search replace parentheses. Oh, so it's okay with the parentheses? Is that all? And just have to have the backslash for the dot? Oh, hey! Yay. All right, so first things first. The only reason I'm doing this is make sure everything's working. Get diff. Okay. And yeah. And we're going to behavior to use a shared pointer reference to the base class when creating a program. Now, we might have to revisit the how we create one. I still like the idea of hiding the constructor. We'll deal with that later. When creating a program. That's fine. Now, get back to our testing and making this work. Okay, so now we're trying to create a bound function. This is where we should have been an hour ago. Yeah. So, what does this do for us at the moment? Well, for the base class, it's going to have something hidden. And this will be, so store the object. Yeah. Available object methods. And this is going to be a map of the type ID. How do we do that? Standard. Is it type index or type ID? I think it's type index. That's the key. And then what is inside of that? Inside of that is going to be a map of a string name, a method name. Yeah. And then what is it going to point to? We need a class that computed expression. Is it just computed expression or... For now. Yeah, for now I'll put it in computed expression. What is it, Corey? You're not telling us. We'll get there. So we're just going to create a type, and we will call this a native bound function is equal to, and what will it return? It's not going to do anything, it's just going to be executed. Well, no, it would return something. It would return a garbage collected value, and it's a function. This is a pointer to a function, a lambda. And what would it take? A vector of garbage collected values? Does that make sense? Is that all it needs? I think so. No, I'm going to use that distinction. I think I'm going to do the garbage collected as a separate value, the this, but have it as an ampersand, so it's a reference. And then vector of garbage collected, again, it can be a reference. It will be executed. Bound to a function. As bound to an object. That doesn't quite make sense, but it makes sense in my head. Native bound function. That's what we're calling it. Native bound function. Okay, so we probably need to pound include some stuff here. Pound include vector. And now this is in computed expression, so we're about to have another potentially ugly thing here when I'm going to need to pound include computed expression. Just see if this fails to compile. Yeah. All right. Oh, yeah, of course it's going to fail to compile down here. Native bound function. And what's this going to be called? These are object methods. And now I'm just going to say I need a get object method. Return the object methods. No, get the object methods there we go. And sorry, just had to. This is going to return a this is ugly. I'll do it anyway. A map of standard type index, standard map, standard string ampersand, and we'll say get object methods. And all right. I guess it should be type info. I really did think it was type index. Am I wrong? I'm looking at some old stuff I did, which I did it completely different, but I'm looking at it for syntax, so. And I will apologize. This it doesn't seem as riveting as I would like for it to have been. I can show you what I'm doing. So it doesn't like type index. And if I say C++ type index, it's a thing. And is it, oh, it's in the header type index. The type index class is a wrapper around a type info object that can be used as an index in associative and unordered associative containers. Yeah. And that's what I was thinking. So is it just that I need to add the header type index? That may be. Is that the right header? Type index, no underscore. Okay. That's better. You know what? I'm just going to make this an ugly hack. As if the rest of this hasn't been so far. All right, so when we create something, I'm going to do this. I'm going to say this arrow object methods sub, and now I need a type index. How do I get a type index? I need to, if I look at this, type index of the type in ID of something. Okay. The type index, wait. was thinking about something else while I did it. Yeah, parentheses. Type index of the type. Is it underscore ID? Nope, one word. Got to be different. Of computed expression string. Okay. That will be a, this is a map, by the way. I can't reference it if I don't know what it is. Computed expression string. And I need that is going to be can I do it that way? I know. You're saying, do it what way, Corey? What I'm wondering is, can I do this? Can I say is equal to, and then that, close, comma, close, semicolon. Now, what goes in here? Well, the first thing is going to be the type index of the type ID of computed expression string. Ooh, I need a little bit more information. Do I? Yeah, I do. That's all right. We'll fix this. No, I think I can do without. Okay. Yeah, sorry. We're good. Now I need an anonymous function, don't I? It's really just an anonymous function that takes a vector of garbage collected values, ampersand, and we'll call that args. Garbage collected, make computed expression integer with a value of 1. I'm working on the syntax here. So, I'm not even knowing if this is correct. And I would need to pound include computed expression integer. It's probably not going to like any of this. And oh wait. Unused. Fine. Args.length. Oh wait, but it requires 2. It should be garbage collected ampersand, and we will call it the target, the this. Has a member name length. Of course it doesn't. Wait. Args size. Now, to integer t. That's what it's complaining about? Would you believe this is compiling? Oh, it's not running, but it's compiling. So what are we looking at? Well, so the idea is that our Tang base has this object methods. And if I look up something, in the case of a string, that's for the case of a string, I should be able to look up something called length, and that will be a function that I can run. And that's that part right there. And of course, it's ugly. By the way, I know none of this is good. I know that. I don't care at the moment. All right. So now, like I said, I don't care at the moment. I'm just trying to get this working. So when I call the dot operator, I need to be able to return a computed expression native bound function. For the first time, now we've got to create a new thing. Okay, so we need to copy under includes. This is not an AST, it's a computed expression. And before we had compiled function, and I think I'm just going to call this a bound function. I don't need native bound because our language doesn't support, but no, who knows what it's going to do in the future. So I will say native bound function.hpp. Sorry, that should have been compiled function to include computed expression native bound function.hpp. We're going to do the same thing with the source for computed expression compiled to source computed expression native bound function.cpp, and we'll also edit the make file, and we only need to add, what am I, we're adding it native bound, so it's going to be after map. Native bound function. Okay. Looking for, that's an AST node map. Computed expression map. And after that, now it's going to be colon, period, comma, period plus 4. Substitute map for native bound function. That's not going to like it. That's all right. Yeah, we need to fix this now. So I need to edit the include for computed expression native bound function and the source for computed expression native bound function. All right, so now I need to substitute did I copy the wrong one? No. I'm good. Okay. %s of the word compiled, and we will call this native bound. Should be 3 of them. We'll do the same thing for the title case. Compiled native bound. Okay. What all does this need? Represents a native bound function declared in the script. All right. What information do we need to know about this? First of all, we don't need to know the arg count. We need a okay, we're in number 8. Number 6. We've got this native bound function type. Yeah, we'll do that. Native bound function, not target. We'll just call it native bound function. Okay, fine. Dump, make copy, equal. Sure, why not? We don't need the get argc or the any of that. This will be the to be executed, and that's going to be all right. And this one, this is an interesting one. this is going to be, we need to store the target that the function, the target object that the function is bound to. And this is going to be a garbage collected value called target. Now, this needs to not be private for right now. And now let's change out the compiled for native. Native bound function. Make a copy. But I can't return this directly. I need to auto temp is equal to that temp arrow target is equal to this arrow target. Now return temp. Okay, so just because our constructor does not take the target, so I want to transfer the target as well. But that's a garbage collected value, so it's just fine to pass on that way. It should be. Not sure. Okay, well, I'll think about it. How about just call the targets make copy? And if it needs to make a copy, it will. All right, equal. If it's a native bound function, cast it to a native bound function, and then a Boolean of whether or not this arrow native bound function is equal to native bound function, and this arrow target is double equal to that dot target. Sure. I don't need these last two. Huh. Okay, just backing up a little bit. line 15. Why is it protected? So if it doesn't like passing in a garbage collected value, which, okay, that's fine. I mean, we can always say this arrow function is equal to may not like that. Okay, let's reread this error message because I'm missing something obvious. In my constructor, blah, 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 on line 15, garbage collected constructor is protected. Oh, well, this one, I know it. Native bound function. So I'm going to edit. Well, no, I don't need to. I can look at my documentation for computed expression. And what's happening on this one right here, so I haven't solved the main problem, but sorry, on line 32, which is down here, this arrow target is a garbage collected value. Does that equal the right-hand side target? And so garbage collected right there. Operator equal will return a garbage collected, but if I need, no, that's an, I'm going to try one thing, and if it doesn't work, I'm just going to remove this part. And what is it? I'm going to say, I'm going to dereference them because I don't remember if I wrote this or not. And yeah, it doesn't say, yeah, we don't know how to compare them. Okay, that's fine. Now, we just have to figure out what's wrong with this one error. Garbage collected is protected, and it doesn't reference a garbage collected except for native bound function. So native bound function is it's a lambda that returns a garbage collected value. Why is it trying to create garbage collected? I just closed it. No. There. All right, so what's the problem? We are storing a native bound and a garbage collected value called target. And so it is trying to create one and it can't. That is the problem. So if I change this into an optional garbage collected there. And what do I have to include for this? Is it pound include, is it memory for optional? Let's just look it up. Pound include optional, not memory. Memory would be for our pointer types. All right, it's compiling. I'm going to there. All right. So we are, in theory, we have something to store a computed expression native bound. Now I'm getting paranoid. Is my recording still going? It is. Oh my goodness. If you're still watching, bless you. Okay, we've got a place to store a native bound function. What we need to do now is on a period operator. Yes. On a period operator, the default behavior. So we need to edit a few files. The include for a computed expression. And I'm going to look for the dunder period. What do I call it? Wait, I haven't done this yet. Oh! Hey, we're adding a new thing. Okay, so in flex, I don't think I've got anything that looks for the period. Double quoted string stuff, but yeah. Oh wait, right here. Well, no, that's a literal period. So if I do that, I can return Tang parser make period, passing in the Tang location. Okay, so I don't have the period operator, but we're about to. Okay, so now we're going to edit Bison. And have a token called period. Okay, since we're adding something new, we need the C++, well, I was going to say order of operations, but that's not the right word. Operator precedence. There we go. And that's C member access right there. So, which end does it go on? Right? This is in reverse order. So, as we can see here, oh, it's on the same as a function call, so we can just do a period. All right. And now we're going to need well, we can just go down to the bottom. We're going to need an AST node for that. Okay. So this is like the index operator. So I'm going to copy the include for the AST node index, but it's going to be called AST node period .hpp, and copy the source for AST node index, and that will be called source AST node period .cpp. Make file, we need AST node period is going to go right before print. Okay. Dot comma dot +4, and this is going to be a substitute print for period in multiple places. All right, now edit the include for AST node period. Edit the source for AST node period. Let's substitute index for period. Do it again for the title case, index for period, and do the same substitution here for period. Now we're back to the header. Sorry, I know I'm just going through here, but this is a lot. Okay, that represents a it's not an index, it is a member access into an object. There we go. All right, so AST node period, it has a, instead of collection, so what we're going to do globally, we're going to change collection to be LHS left hand side, and what's the right hand side? Well, it's saying index, but that's going to be RHS. Now, so LHS, the left hand side, into which we will the left hand side on which the member access will be performed. The right hand side is going to be the right hand side identifier. The location, that's fine. Now, We're not going to have a shared pointer as the right-hand side. We're going to have a string. That's the right-hand side. That should be fine. Compile. That should be fine. Left-hand side. The right-hand side is a... do I need this? I don't think I do. Okay, left-hand side and a standard string, right-hand side. And now we're in the actual thing here. So we need to do the same thing. First of all, collection is becoming left-hand side, index is becoming right-hand side, and now it's a string. That should all be fine. This is a period, and the left-hand side is the left-hand side dump, and then the RHS, the right-hand side, is going to be this arrow. Indent plus 1, 2, 3, 4 plus a new line, because everything adds a new line. All right, that should be right. To compile pre-process, we only had to do it to the left-hand side. The compile, this one's going to be interesting. We compile the left-hand side, and then the right-hand side is going to be a how do we tell it what string we want? We have to store it as a string, basically. I don't think I like that. Okay, let's see. How did I do this when I did it with the object? So it was the AST node. Was it just called an object? Map. So on the compile pre-process, I did a string and called pre-process on that. So that's what I'm going to do here for the right-hand side. Instead of item first, it's going to be this arrow RHS. Okay. And now, for the compile, it is this arrow RHS, the right-hand side, and call compile, which will create it as a string. So that's fine. So it'll only be created once. And why would we want to do that? Because I'm assuming we may call the same thing over and over. So it's a what's the word I'm trying to use? Cost saving, space saving measure. Yeah. All right, so now program add bytecode. A period bytecode. Doesn't exist yet. We're about to write it. And then we don't need the get collection or get period. There we go. And now let's edit the include opcode, and so we've got index and slice. I think before that we'll add the period, and that will be pop the RHS pop LHS push LHS.RHS. Okay. Now we're going to edit the source for program dump bytecode. Sure. And that was right before the index. So we'll just, the next index, there we go. And instead of index, we will have period. Period. Okay. And now we're going to edit the source for program execute. And again, index, index, except now it is brain just died. Period. Definitely need to do a stack check of 2. This is going to be the member. I'll use member. And then container. How about just LHS and RHS? Now, we want to container arrow. Well, we kind of want to. We're going to say auto temp is equal to that, and if the type ID of temp does not equal the type ID of computed expression error. And why did I stop? Because I realized it shouldn't be the type ID of temp, it should be the type ID of star temp. If it does not equal that, then we want to say no. I want to say if it double equals computed expression native bound function. So if it does, then do a static cast to a computed expression native bound function of star TMP. Oh, and that should be an ampersand. Right? And I'm going to say dot, and now this is where my mind fails me. So I'm on number 11. Let's go to just B1. Target. Target. Target is equal to the left-hand side. Now, target is a, should I say, I think I have to say that. Or will the equal just work? Let's see if the equal just works. Either way, then I push it back. So if it's an error, it'll just get pushed back. If it's anything else, it'll just get pushed back. But if it is a native bound function, I'm going to set the target of that native bound function to be the correct thing. All right, now, what have I forgotten? We never finished Bison. Okay. So what do we need here? We need a, oh, right here, AST node. Where's index? I'll just put it right. Period. All right, and now as an expression, pipe, and what would this look like? It would be an expression period identifier. And all that I need to do is say make shared, what is this? An AST node period. And what do I need to pass an AST node period? $1, $3, and @1. I think that's right. Okay, now we're ready for the onslaught of all the errors. You know what? Because I added an opcode, I'm just going to go ahead and clean it, start from scratch. Big picture, what we're hoping for is we've added now this dot, this period operator, so that should create the AST node. When we compile it, it's going to, of course, have the left-hand side, right-hand side. Oh, not declared, and that's in period.cpp. And that is 7. String. So we've got here it is, the AST node. When it compiles, it will of course compile the left-hand side and then the right-hand side and add a bytecode that says do the period operator on them. When the period operator is executed, it should call the period operator and then set the target. Now, we've got a container was not declared in this scope. Oh, container. Program execute. That's why. That's 11. And the reason is because I changed these names to right-hand side and left-hand side. So, now I haven't written this dunder index, so it's about to complain about that, but that's okay. We'll deal with that. It should be the RHS. No, I have my left and rights messed up. LHS, the left-hand side, not indexed, period. That doesn't exist yet. Left-hand side, period, right-hand side. Now tell me that period doesn't exist. Good. But what other stuff is it saying? Doesn't know what computed expression native bound function is. Well, that's because evidently I haven't native bound function. Those errors should go away. Now it just doesn't know what a period is. Okay, that's fine. We can edit the computed expression HPP. There we go. Delete that. Now go to buffer 3, which we're here. Okay, so where? Oh, here's index. Let's just create another one, and I'd put period before, right? So period. Perform a member access period operation. So it's going to be, we need how about member? The member expression provided by the script result. Okay, and we'll call this member. All right, and now we need to edit the source. The source for computed expression dot. Oh no, wait, that's not all we need. I just remembered something. So period, we're going to need to pass in a shared pointer to Tang base. And we will call that Tang. We're going to have to pass that in. All right. And now it's going to say it doesn't like now what we've done on the period thing. That's fine. B11. All right, so when we call period, we need to pass in Tang, and that is this because we're in the program thing that's running. So this arrow Tang. Oh, not been declared. Need to edit the source for computed expression.cpp. Oh, well, first of all, that's number 13, but it's not liking computer Tang base is not. Fine. It's always scary when you mess with these header files that affect everything. Native bound function is not a member of Tang. Why is it doing that? I know why it's doing it. See if this will work. It's always when you see the files and see how they're all interconnected, you're like, yeah, this turns into a spider web. I don't like doing that, but sometimes you have to. All right, so what's it not liking? Computed expression. Optional. It doesn't like that, which is in program.hpp. Okay. It's again it's the order of the includes that it's not liking. Do I need to? Computed expression. Haven't gotten up to garbage collected yet. Wait, but program compiled. Garbage collected compiled. Maybe that was it. I'm not expecting anything to pass. Okay. The Dunder period doesn't exist. Okay, I can deal with this. Let's edit. No, wrong window. We're going to edit the source computed expression.cpp. And let's see. Look for index. Look for the next index. All right. Now, instead of index, it's going to be period, and it's not going to be a maybe unused. We're going to have a what am I calling these? Member and Tang. Yeah, member, and then a shared pointer to Tang base. There we go. So this is member, and then it's not a const, and it is not that, it is a shared pointer to Tang base, probably ampersand, and we will call this Tang. And up at the very top, we're going to need to pound include Tang base. But that should be fine now. Should be. I'm going to at least say unused just so I can get it to compile. Don't know how. How about no member found? We have failing tests. That's always a good thing in this case. All right, so what do we want to do? Well, auto members equals Tang arrow, because it's a shared pointer, and let's edit the source for Tang base, not source, but the include for Tang base. Oh, just say call get object methods. Object methods. Yes. All right. That should be fine. Oh no, I'm gonna leave that there. And now auto methods is equal to methods of type index of type info of asterisk member. That should work. And the not member, not member, this. Now I need to say if the type ID of member is equal to the type ID of computed expression string. This should be the first check that we actually do. If that, then there. Auto name is equal to static static pointer cast, static cast, I forget. I don't know. It's late. I've slept since then. C++, static pointer cast. Yep, that's it. String of, and what would it be? Member, arrow, get value. That should be right. But this is a computed expression, so I do need computed expression string. There we go. So get the value. So if I edit the include for computed expression string, just to make sure, at the bottom, get value. Okay. Let's just go back to 2. How about that? I think I like that better. If methods.count name return methods.at name. Sorry, just thinking through. There we go. I could do this as if auto this type is equal to dot count this type all right. This type is equal to type index if count then this type. There we go. String name is equal to static pointer that get value, else member not found. Okay, now we're not liking any of this. Type info is not declared. Why? Probably because I have to pound include it, right? one word if I remember correctly. Type ID. Why did I say type info? No idea. $126. That's where I am. Member should be, yes. That should be an ampersand, but still, I don't think that that's going to fix it. It's not a static pointer cast, it's just a static cast. There we go. So, could not convert 128. Oh, of course. Garbage collected make, and what am I making? Computed expression native bound function. I'm about to have to include it, I know. And I'm still missing something, but we'll get there. Include computed expression native bound function. What does the constructor look like? I need, oh, just the function, and then I set the target. That's right. Target is equal to this. So no, wait. Nope, I don't need to. It'll happen. It'll happen in the opcode. Nothing's working. Oh, because there's one other thing I haven't done. I haven't said how to run it yet. So let's at least do this. Test. Down at the bottom, and let's just do this one here. Cout p1 dot dump bytecode. See what it prints out. This ought to be an interesting one. Null val, null val. So that's, I'm assuming, A, then B, and then string hello world, length, and goodbye. So it did get the dot length. Peak 2, 0, 1, 2. That's hello world. Poke that into A, 0, pop. Okay. Peak 0, that's A. Peak 3, which is length, period. Poke that into 1, which is B. Pop that. Peak 4, which is goodbye. Poke that into 0, which is A. Pop. Peak 1, which is B. Call it. Print the result. Pop. Peak 0, which is A. That should have been A dot length. Oh, but this will let us see that it only does length once as well. And it does. Yeah. I'm happy about that. All right. So now we just have to edit the source of program execute. And we're looking for, what is it? Call func, isn't it? Look at this. Okay. $500, or not 500, but let's just yank 32. So I'm line 505. Why? So I can go to the top and just say, oh, native bound function. We got that. Go back to 505 then. So compiled, let's just call this native bound function. Native bound function. And do we need to verify that the correct number? So it should be putting argc. And I don't think I'm doing that when I compile. Oh, no, wait. The function call, we'll put that on there. Okay, so argc. In that case, if argc does not equal function convert of, I don't not get argc, but so this is a computed expression native bound function. So it's going to be native We're not storing how many need to be in there, are we? No, we're not. We are not. All that we're going to do is we are going to just pass that in. And it's up to the calling, the function being called to verify that it has enough arguments. This is wrong. We don't need to do any of this. So when a function is being called, what order does it put it on the stack? If we look at the source for AST node function call, when it compiles, it pushes each argument onto the stack in order. Yeah, and that's where it calls a function and then with the size after it. Yeah. Okay. So what do we need to do here? We need to populate and for the function. If I do this, will that reserve? I never remember. I guess I'll find out in just a moment. I need to now get these off the stack. But what's a fast way to reverse a vector? Didn't I already write this? No, I didn't. Blah, 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 yeah. Yeah, I know I can do that. I mean, I've already known that. like any of these. Can I just do auto iter is equal to stack dot end minus argc? Well, also we need to make sure that we've got enough things on the... Oh, we've already made sure that we've got enough stuff on the stack. Okay. And then we would say for int I is equal to 0, I is less than argc. No. While iter does not equal stack dot end. I'm going to call this argv. Argv dot pushback star iter. That should do one after another. And then if I do it as star plus plus iter, and then for int I is equal to 0, I is less than argc plus plus I, stack dot pop back. That's going to be there. So populate the arguments for the function. Argv for the function. I can't do this. With which to call the function. There we go. That's bad as well. To use when calling the function. How about that? So we've got an argv, and we're going to say stack n minus argc. We know that that's there because we've already done the check. While the iter is not the stack n, we're going to push back the value at the iterator and then increase the iterator. And then we're going to remove the arguments from the stack, pop them back, and then stack dot push back what? Func convert dot native bound function, and we pass it argv. Is that it? Can't be. I've got to have made a mistake somewhere. All sorts of fun stuff. Let's see. So garbage collected, So function converted. It's private. That's new just to me. I probably wrote it that way, but okay, there. Native bound function. Oh yeah. I need two things. I don't remember what it's called. Target. Now we should there is make sure that there's a function to execute. How do we do that? If conv dot native. Nope. Target. So it's not that there's a function to execute, but make sure that there is a object that was bound to the function. If that exists, then we call, so target is an optional. I think I stopped in the middle of a line. Func convert with UNC, not fun conv. And 509. Wait. What do you not like? Is it reserve? Well, I finally. Whoa! Hey! 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 Look here, we got a 0, 0, and then 2 zeros. So it called it twice. So I don't even remember where I wrote this code. It's been so long. Well, it's 2 a.m. That's why I'm seeing double here. Actually, quite literally. I think it was in source Tang base. There we go. And I just said args.size. But what I'm going to do instead is to say if type ID of target is equal to the type ID of computed expression string, then return an integer which is the yeah. Sorry. I was like, is this already a computed expression? No, it's not. But we're going to say static cast. No. Yeah, static cast to a computed expression string ampersand of star target dot get value, which is a Unicode value, dot length. Oh, wait. Well, it's gonna say I don't know what to do otherwise, right? I have to return something. No, it's got to return a garbage collected. I can't go from an error to a garbage collected. Can I do that just for the moment, just to see if it will compile? It's putting a lot of extra spaces and I don't like that. Why? I'll fix all the extra spaces in a moment. Right now, just moving around some stuff. Everything passed. I have no idea. No, I do know why, but I mean, it's like, wasn't expecting it to happen that quickly. So, what's happening is it is on Tang base, it is validly pulling this computer expression string. It's asking for the length, and it's running this code, and it's just working. Wow. If we look at the test, we can prove it, right? Because this right here, just add a space. This one should fail. But it got the right lengths of those strings. And in fact, do I have a Unicode string here? No, I don't. That's all right. I'm not worrying about it anymore. I'm exhausted. I'm not even going to edit this video tonight because it's... I recorded 2.5 hours and then the video crashed somewhere in there and then this segment's going on another hour. Yeah. Let's wrap this up, shall we? Oh boy, lots of changes. Is there anything that I can do I mean, it's all just kind of one big thing. Native bound, yeah. The bison stuff, I added the period, but then I have to add the AST node period. And when you add the AST node period, well, that you have to compile it using the opcode. When you use the opcode, you have to everything's interrelated. Yeah. What did I add? Such a simple line. And it was 342 lines. 3 deletions. All right. This ought to be interesting. Do I still have the other? Yeah. Go ahead, finish, and I'll reload. Now under files, I think before. Just under files, I thought it would show up. Never mind. Well, there's test source. Which one was it? The garbage collected that wasn't showing up, I don't think. I think that's a new one. And see some of the complicated arrangements. What about ternary? Well, yeah, it's getting there. Of course, the stuff in that. And then our locations, which is in generated. Yep. Classes, we've got our new classes, which is the period. There we go. Yay. And then the computed expression. Native bound. It's there. Always happy about that. So, what episode are we on? It's 50 something. 56? Episode 56. That's a lot to push. Well, didn't I change some pretty core stuff? I think so. There we go. Oh, we are just under 9,000 lines. And I thought we were going to have 10,000 lines. At this rate, well, it's... Okay, what do we have left? We still need to support regular functions, just library type functions. For you to be able to say, for example, I want a date library. Although date won't be included in this 10,000 lines. I'm just saying, for example, I want a date library and give me the current day, or format a date in a certain time. Or I don't know, or maybe just something about Tang itself, a system thing that can give me the version that I can check against, or stuff like that. Or maybe a string library that exposes a little more of the string manipulation stuff without it being attached to a string. Maybe I was going to say a conversion library, but I would actually think a float format, maybe, library to format floats, because right now they default to 6 decimal places, and what if you want something different? Well, Yeah, all sorts of different stuff we could do. But we don't have that. We don't, and that would be a native function thing. You know what? What do we? Oh, everything's passing. That's always a good thing. And if we edit the include for tang.hpp, oh, of course, got our optimizations. This I'm going to leave these encoding things on the to-dos. We still have maybe saying, what are these? Up here, half-formed ideas, but I think I know. Ranged fors and iterators, we have that, so I'm going to delete that. The use syntax, we do have objects, but we don't have the assignment. But you know what? I don't think I want assignment for the dot operator. In fact, I'm pretty sure, I know I don't. So we got objects. Functions on objects, bound objects, yep. We haven't done our template scanning. We haven't done comments, code comments. That up here, we ought to do that pretty quick. That should be easy to knock out. Oh, a math library. That's a good idea. Min, max, round, all those. I'm going to add this here. Potential tail call optimization rather than loop and switch case for VM. That's a huge one. I've been experimenting with this on ways on how to make our VM operate as rather than right now it's a big loop that goes through, and every time it does a switch, down to something, and it's not the most efficient. Whereas alternatively, I've been looking into, well, can I write it in such a way that each opcode is its own little function, and they call one another, and yeah, that's what I mean by they call one another. So and with a tail call optimization, so that means it's actually not doing the overhead of a function call, but it will just jump to the right place in the code. That is one of the things I'm looking at, and I have a proof of concept. It's just not on the scale as big as the current virtual machine. So there's still plenty of things to do. So I think we're going to go past the 1,000 line mark, 10,000 line mark, because that's only 1,000 away. And we do have a lot of functionality right now in the 9,000 lines and 2,800 lines of comments. But yeah, it's a lot. And I've been trying to record a video every day, or at least try to get one out every day. I was ahead, and then I got behind, and now I'm only barely ahead. So, and then this one, well, I think I'm at like almost the 3.5 hour mark. I'll try to see if I can fast forward through some parts, but even that takes a lot of work. So we'll see. Having said all of that, I don't care how tired I am. I love this stuff. I love programming, and I love solving these types of problems, and or designing a system. That's the kind of, I like coming up with solutions, and if it can help you out, because one of the reasons, and I know I'm rambling, but it's at the end of a 3.5 hour video. If anyone ever sees this, I'll be shocked. But I'm going to say it anyway because I want it out there. it's hard to find information on doing this. There's a few books out there. There's a few videos. Well, not very many videos. Most of them are toy languages. And then, of course, there's classes you can take in college. And those aren't bad, by the way. But if you're watching this, you know how many. I mean, this is episode 56. And each episode, very few, only one or two have been less than an hour. Most of them have been an hour and a half, 2 hours, 2.5 hours. You're not going to write this, a language like this, as a homework assignment. It's too big. And so, even though there are classroom exercises on doing this, most people come nowhere near doing anything like this. And I'm not saying that, this is the best example that there is. No. There's so much room for improvement, and I'm not. Well, because I was going for a specific type of templating language, I considered very strongly about whether or not I should include closures. I like closures. I think they're a cool feature, but I don't think it's appropriate for this type of a language. And there's quite a few other things that is like, well, I'm not trying to become PHP. I'm not trying to become JavaScript with this. I have a very specific use case, and if I can get something that's decently performant and that I can use in the way that I want to use it, and it solves the problem, I think it's well worth the time investment that I'm putting into it. And if you can get something out of it along the way, I don't care if it is me floundering around saying, why won't this compile? For beginners, that's a huge thing. One of the hard things for beginners is they'll watch a video by someone and it just goes off perfectly, and that's great. It shows you how to do it right. But one of the hard things is, what do you do when it goes wrong? How do you figure out what the problem is? And I'm not going to claim to be an expert at it, but I'll say this: I'm never scared of it. Sometimes I'm scared whether or not I can do it on the video in the time that I'm trying to allot for it, but I'm never scared that I won't be able to figure it out, and that's just experience, right? But that doesn't mean that I'm perfect. I'm far from it. There are times, you've seen it on this one, where I started and, for several hours of solid coding, I end up writing hundreds of lines spread out across 15 files before it will finally compile, and all of a sudden it's like, it works, But it took a lot of, what's the syntax error here, And part of it's probably the fact that I'm not using an IDE, but I don't care. I like using Vim. And as a programmer, I like reading the error messages, understanding what's happening, and making sure that I understand what type is which. I'm often even hesitant to use auto, just because it can hide, the type, that if you have to specify the type as opposed to just saying auto, whatever, if you have to specify it, then there's actually a lot of merit to that. If we didn't have auto, there wouldn't be any ambiguity about what the type was, right? It would be like, you say what you think it is, and the compiler will tell you, no, it's wrong. What you think it is wrong. So, that's a nice. But I use auto. You can see here, but I only use it when I'm very confident in what it's producing. But overall, I have gotten value out of watching other programmers, and even mess up and do all that other stuff, and even if it's just like the 1 or 2 times that I've loaded up GDB really quickly, just to see that and see what's the output, what am I looking for. Hopefully that's beneficial to you in some way. All right, it's late. I'm going to go to bed. As always, I doubt anyone will ever see this. But if you're the one person who actually cares about this and finds this interesting, then know that you're the person that I'm doing this for. That is, I hope it's helpful to you, and yeah, hope you're enjoying the journey. Thank you. Have a great night. Bye.